Kirloskar sir, our guest speaker of the session, Engineer Muhammad Hashim, dear fellow colleagues, participants, and all the viewers. A very warm good morning to all of you. Today's session is also very personal and special to me, as our speaker, Mr. Muhammad Hashim, is a very close friend of mine. So, with utmost joy and pride, I, Anu Murli, Assistant Professor of Department of Civil Engineering, on behalf of the entire Civil Engineering Department of Vidyavardhini's College of Engineering and Technology, Vasai, Maharashtra, wholeheartedly welcome you to this webinar session. Also, a very huge welcome to all the participants and all the viewers out there who are the real soul to our webinar. One of the hot seats of civil engineering for ages has been the structural consultancy. To enlighten us about this hotspot in this summer, we have Mr. Muhammad Hashim, who has more than a decade of experience on this topic, joining us live from Dubai. Mr. Hashim has hands-on experience on engineering department, coordination and developing pre-engineered buildings and structural design as per client requirements, and is skilled with professional degrees and real-world experience of more than 10 years. He has garnered his BTech in Civil Engineering in the year 2008 from NSS College of Engineering, Kerala. Further, he achieved his MTech in Structural Engineering in 2010 from NIT, Tamil Nadu. His career began at Kirby Building Systems Limited, Hyderabad, Telangana, as a design engineer in 2010. He then worked with Mohd Building Systems in Sharjah as a structural engineer till 2015. Currently, he is working with Trojan Holding Abu Dhabi as a senior structural engineer designated as a head of the department, where his work includes developing, reviewing, and approving engineered documents and drawings, coordinating with various engineering departments, preparing engineering schedule, resource planning, identifying design changes, etc. Furthermore, he has also presented international conference papers on ocean, offshore, and Arctic engineering at Shanghai, and seminars on multi-legged articulated tower at IIT Madras. His major works include military industrial facilities, bridges and boardwalks in Dubai, Abu Dhabi, airport works, Dubai Parks and Resorts, Sindh State Assembly Hall in Pakistan, JSW Steel Bellary Plant Extension in India, seawater desalination plant in Ghana, satellite uplink station structure in Tanzania, Hindustan Coca-Cola processing unit at Hyderabad, and several malls and warehouses across UAE. With the experience of handling more than 100 projects of different type, complexity, challenges around the globe within such a young age, we're so happy to listen to a very young and talented structural engineer. For the next 1 hour, Hashim would be giving us insight on the topic basics of structural steel construction. Thank you. I request Kirloskar sir to please say a few words.
Hello, Mr. Hashim.
Hi, how are you?
Can you hear me? Yeah, hello. Good morning.
Yeah, good morning. I can hear.
Yeah, great. Nice to see you. Well, nice, nice to
meeting you.
know about your quite impressive biodata. And also, I'm very happy that you did your MTech from NIT Trichy in structural engineering, which is very much, prestigious and reputed institute. Okay, this is just a casual 2 minutes discussion. I will come back again at the question answer session.
Sure.
So I just heard that you are almost all 9-10 years experience is from abroad. So it is really great to know about that also, because our students would be also interested in the, as I say, that from the beginning, just after your graduation, you have, after 1 year or so in India, all your service has become in the Gulf only. Great. So how is the situation at Dubai at present? Lockdown, is it there? And work from home, or some structures are going on, work is going on?
Here, thing is that it's not completely locked down. There's a partial lockdown, you can say. Some of the sectors are closed, and construction sector is going on. It's not affected. There are some problems because of the COVID issues. There are some regulations. Apart from that, construction industry is going smoothly. Many offices, what they are doing, they're reducing the strength at office. They're taking the technical, they're asking the technical department to work at home. Whichever department who can work at home, they are doing it. So reducing the strength and adhering to rules of the government. So far, it's
Okay.
going good.
Yeah. Okay, sir. Please continue. Carry on. Thank you very much.
Thank you. Good morning, viewers. Good morning, all. So today, as you all know, we'll discuss about basics of steel structure construction. Here in this session, I'll try to explain different stages of steel construction, right from the start engineering through detailing and production of steel members and its erection. You know what it is steel, what steel structure. Any steel structure which use its structural components as steel to carry the loads, and for the structural stability, we call it a steel structure. You might have noticed many steel structures across. And nowadays, it's getting more popular because of its many advantages. Like, as you know, the steel structures, our construction is very fast and it's prefabricated. Most of the steel structures are now prefabricated. All the structural elements are fabricated in factory and it is taken to site and connected together. Because of that, the construction is very fast, the quality is good, and it has very less environmental impact. Because of all these things, now the steel structure is getting more popular and more in use. When you see about steel structures, there are many applications of steel structures. It is used in offshore structures for offshore towers, and it's used in onshore structures for many use. In this, we'll discuss about the onshore structure construction. Based on its application, it can be classified to industrial structures, tower crowns, bridges, hangars, warehouses, modular structures, and residential buildings. You might be knowing from the name itself, industrial structures. Towers are those coming on top of the tower, which will be an architectural features, and it will be used to cover the MEPs and other work items on top of the tower. And when you see bridges, hangars, warehouses, modular structures are very relevant to current scenario. With this pandemic going on, modular structures are very widely used to build structures in a very fast manner. Modular hospitals are being made, modular quarantine camps are being fabricated, modular clinics, stuff like that. Is modular structures means those fabricated, assembled, everything will be ready at factory and it will be taken to site and just place it in position. So because of that, it is also getting, when you need a very fast construction with then modular structures are very common in use. And when you see about the structural components, based on the steel sections used on it, again, steel structures are classified. There are conventional steel buildings, PEB, pre-engineered buildings, light gauge steel structures, we call it as LGS steel structures. Conventional steel buildings are those in which the structural members will be made from standard sections. Each country have their own standard sections. Many, like India, we have ISMB, ISMC, and when you go to America, there is W sections, and in Europe, they're using IPA, IPEB, HEB, like that. And in British, it's like UB, UC sections, universal beam sections, universal column sections. These are wide range of standard sections available in particular market with specific dimension. So this dimension will remain same through wherever it is you get the structure, get the element. So this way of construction is conventional way, because it was used conventional way of structure where standard section will be used. In advance, there is pre-engineered buildings where built-up sections are used. Plates are welded together to form the required section. Plates are welded together. For example, if you need an I section, plates are welded together to form the I section. Here, the advantages of this method is that you can use the steel thickness according to your requirement. You don't need to use extra steel. And this is relatively new when you consider conventional structure, when you compare with conventional structures. Here, the approach is that you will do the analysis, you will see the stresses on the structure, and your profile, your section will be shaped to according to that one. Here you can see from the sketch, this is a simple gable frame, and this is the bending moment diagram of the gable with a gravity load. Here you can see the moment is maximum at the haunch portion. This is the haunch where the column and rafter get connected, and this portion we have a maximum moment. And when you see the real structure, you can see the shape. The shape of the frame will follow the moment diagram. So the advantage in this is that you don't need to use more steel. For example, when you use conventional steel structure, you'll be having a straight member. The column will be straight member. So you will design the column for the moment here, and the same section is provided throughout. And this will result in more usage of steel. But when you go for PEB, you'll design this structure based on the moment, and you can taper it to reduce the depth towards the supports. And also, when there is more shear, you can just increase the web thickness and make it safe. You don't need to get all the members to be heavy at that For example, here you'll be having maximum shear force, and you need to just increase the section thickness in this area, web thickness in this area, and you can reduce at the when you go towards the ridge. So like that way you can reduce steel. So when you go, this is an advanced technology, advanced method of construction where you can save a lot of steel. When you compare with the PEB to the conventional steel, for a normal warehouse, if you are using PEB method, you can save like 20 to 30% of steel tonnage. Another steel is light gauge steel structure. Here, steel thin sheets are used, cold form steel sections, to make the structural element. In cold form, very thin sections are used. These thin sections are bended to get desired profiles like C, Z, hat sections. And these thin sections, small sections, are used to prepare trusses or panels. In these pictures, you can see there are trusses formed of light gauge steel members and panels formed which will be act as a structural element. The advantage of this one is that it is very light. You don't need any machineries to erect this steel structure. You can workers can take it by hand and fix it in place. So this is very convenient for a small scale of construction. So these are different types of steel structures. Now we'll see different phases of steel construction. As you all know, it starts with engineering. Then once the engineering is done, all the details are ready, procurement will be done, steel material will be, the raw material will be procured, and production will be done according to the engineering details, and the producted items will be erected. In engineering, there is two stages, design stage and detailing stage. In the design stage, the structure frame is identified, the frame structural framing system is finalized, the section sizes are finalized, the connection details are finalized, the anchor bolts, its reactions. These things are finalized in design stage. And once this is finalized, it is not sufficient for the factory to design, to fabricate. For that, a detailing stage will carry out where 3D models will be created and fabrication drawings will be produced. In design stage, as I said, first thing is to make structural system. Based on the architectural drawings we receive, based on the project specification, the structural arrangements will be done. The columns will be placed in position, the structural members for the stability will be arranged, and it will be designed for the given loads. Here I've shown a simple warehouse building where some simple arrangement of a structure. The main element in this structure is this main frame. You can see a main frame column and main frame rafter. This will give the stability of the structure in lateral direction, and bracings are provided for transverse stability. And you can see girds which connects from column to column. These girds will be used to fix the wall cladding, and it will support the wall claddings. And you can see purlins here which spans from rafter to rafter, and this will support the roof cladding, and it will transfer the weight of the roof to the main structure. So this is a general arrangement, and based on other requirement like doors, there will be door jambs, and other secondary members will be provided based on the requirement and architectural features. So this is the first step. You will make the structural system, you will analyze the structural system, you will then design the structural system for the loads and the stresses on the system. For design, there are different codes used across the world. And here in Middle East, AISE 360 is used. It's an American standard were for the steel sections. It has two different methodology. LRFT, which is something similar to limit state design in Indian code, and there is ASD, allowable stress design, which is something similar to working stress design. And in India, IS 800 is used. IS 800 is the code for steel design, and in British standard, BS 5950 is. ASTO is also used for bridges and other highway-related structures. It's also an American standard. AISI is also an American standard, which is used specifically for light gauge steel structures. So once you design the steel elements, once you finalize the steel sections, next step is to design the connections. Connections are generally two types, mostly bolted connection and welded connection. Now, most of these steel structures are prefabricated in factory, and it is just connected at site. Because of this, bolted connections are most common to avoid site welding, because site welding will be having quality issues. So most of the clients will ask to avoid site welding. Because of that, field connections will be bolted and factory connections will be welded. It's not 100% like that. There will be changes based on the site requirement and project requirement. When you see about connections, you have to design the connections for each different structures, interconnections. And apart from that, the connections need to be arranged considering the logistic limitations, the lifting limitations. For example, if you have a beam of like 30, 40 meters, you cannot fabricate it as one piece from factory and it cannot ship to the desired location, because you'll be having problem in transportation. Your trailers or containers will not be that big. So you cannot transport a 30-meter long beam. Then you have to provide splices or connections in between. So these things need to be considered at the design stage, and also your lifting capacity. If you are using a tower crown, making a tower crown structure, you'll be using tower cranes. So the tower cranes will be having limitation that it can be taking like 6 ton, 7 ton, 8 ton. So you need to see that one. So each beam should not cross that weight. Then you'll be facing difficulties in lifting and erection. So these things need to be considered while assigning connection points. These are some softwares used for design for structural connections. There are many softwares, and I'm just listing some popular softwares. StatPro is widely used for steel structures. SAP 2000 also is used. MBS is maybe relatively new to all. It is specifically for PEB structures. It's metal building system, which software which used for warehouse building. It's give complete design. Once you run the MBS with all the inputs, it gives complete design of frames, purlins, bracings, everything. So it's a complete package design software. It's used mainly by all PEB companies. And ETABS is generally used more for concrete structure, but it can also design steel structure. For connections, again, there are many softwares: ramp connection, Procon, Idea Statica, Limcon. These are few examples. And many companies, most of the big companies will be having their own spreadsheets for connections. So once you finalize the section, arrangement, sections, and connection details, this give full details about the structure. But that will not be sufficient for fabrication. For fabrication, you have to go through a detailing stage. In this detailing stage, you'll prepare shop drawings and NC files for fabrication and erection drawings for steel erection. Here, each element is detailed with all the dimensions for fabrication. And it's a tough process which needs a lot of concentration, and it takes a lot of time. This, for example, if there is a structure, it will be having thousands of elements. So you need to detail each element with all the dimension for it to fabricate. So this is the main process in detailing. And nowadays things are easy because there are many 3D softwares which can make all complete 3D model, virtual model with all the elements in it. And this approach is not only used by steel structures, it's used by almost all construction sector, and it's getting more popular now, which is called BIM approach, building information model, which will create a complete virtual building in which all the elements, all the items in the structure will be modeled in 3D before starting the construction. This allow the engineers to coordinate between different contractors, different trades, and if there is any clash between one, for example, I have a steel structure and there will be some MEP decks going through the steel structures. These decks should not clash with my MEP, my steel structure. So these things will be coordinated in this phase, BIM approach. So all 3D will be there. So we can see whatever items are in steel structure. You can visualize it. So it will give a better view on the structure. These are some advantages. It will maintain accuracy in dimension when you consider steel elements. It will maintain accuracy in the dimension of each part, and it will give better overview. And once the detailing is done, once the model is complete, you can get complete material takeoff. It includes all the bolts, number of bolts used for the structure, sizes of the bolts, member sizes, quantity of each type of members, each thickness of plates used. So all details will be received in this process. I'll just show one 3D model. I'll just share one 3D model to understand better, and we'll explain further with that 3D model. This is one 3D model of a crown structure. As I told, you can see all the elements in this, all the bolts, everything is modeled to the actual. So it will resembles the actual building in 100%. And with this, you can use it with other contractors. For example, here you can see these brackets. These brackets are meant to support the cladding mullions. For the cladding, there will be mullions coming, and these brackets are to support the mullion. So once we give this model to the cladding contractor, he will put his mullions here. So he will understand that, okay, I have the supports at correct position. For example, if his mullions are required at this position, he will cloud it and tell, okay, we need to move this bracket to this location. So this type of coordination is possible with this approach. And you can see all the bolts, and even we can check the clash check with steel to steel member itself and with other trades. So that's the main advantages of BIM approach. So the complete building is modeled, and all the elements are modeled, and then shop drawings are created from this model. When you see about shop drawings, there are two sets of shop drawings. One is single part drawings and the other one is assembly drawings. Here you can see this is single part drawing. From the model, I'll explain what is single part and what is assembly. For a structure, there will be thousands of members, thousands of elements. So here, if I select here, this is one assembly. This is, here you can see this here, this is connected to anchors, and here there is a splice provided. And when I take this one alone, this will be shipped from factory as one piece. So it is called an assembly, which will be assembled together inside and will be shipped as one part to the site. Here, this assembly is formed by connecting many small elements, like this is one element, this is one element, this is one element, and this one is another element. So many elements are connected to form this assembly. So each element is called single part. Here, if you see, when I click, you can see this is only selected. These plates are not selected. Each plate is different element, and it will be having a different drawing as single part drawings. So two sets of drawings will be created. One is single part drawing for this particular member alone. Likewise, there will be thousands of single part drawings, and then these single part drawings will be used to form assembly. Here, this is one single part. This is this member which I've shown here as a single part drawing. That will be having a unique number. The softwares which is now 3D, there are many softwares for 3D modeling like Tekla, Rivet, and FrameCAD. FrameCAD is usually used for LGS structures. So there are many softwares for 3D modeling, and most commonly is for steel structures is Tekla. So when you model the Tekla structure, the software will identify the elements. If one particular element is having dimensions same, it's repeating in many location, it will give a specific number for that one, and this number will be shown in the drawings. And the same element which will be, if they have an additional hole or something, it will be having different numbers. So a unique numbering system will be followed for every single part. So if there is 1,000 single parts in a particular structure, it will be having 1,000 numbers. If there is repeating elements in that particular structure, it will follow same numbering. So these single parts drawings will be going to the factory. So they will cut the raw material based on the single part drawings. Once all the single parts are ready, then comes the assembly drawings. Here you can see, I'll just zoom it, this number WEB303003. That's the same number which you have seen in single part drawings. So in assembly drawings, it will reflect the single part drawings and it will show how to fit the single parts. You can see here, all the dimension for fixing each item is shown here. So this drawing will be used to make the assembly. Likewise, all the assemblies are created and it will give complete structure elements. Once the assembly drawings and single part drawings are done, it will be given to production for fabrication. And another output from detailing is erection drawings. You have the assembly drawings, you have the single part drawings. Factory will fabricate the assembly based on your assembly drawings. And each assembly we will be having a unique number. Like I said, for single part, there will be different assemblies. For example, this column assembly, this is one assembly which I've shown before. Same, there is another assembly, but it has different number. This one is CL3 and this one is CL2. The difference is because there will be different plates connected. Maybe it looks similar, but there will be different location of connection plates. So if there is any single change to one assembly, it will be having different numbering system. So one assembly will not, two assemblies with different features will not have same number. This will help the erection team to place the members in exact position, and thus they can avoid the coordination, avoid the time wastage at erection. So these are the main three output from detailing: single part drawing, erection drawing, and assembly drawings. And as I told, you'll get complete material list also. So once the material list is ready, complete material takeoff will be given to the procurement team, and they will procure the steel material based on that. And the single part drawings, assembly drawings, and NC files are given to production department. This NC files, it's computer and numerically controlled files which give the details of single part drawings. In single part drawings, as I said, it gives the length of the element, and it gives the details of the holes or any notches, etc. This information is stored in this NC file. And when you give this NC files, this NC file will be used to prepare single part drawings. Most of the machines can read these NC files, and it can use these NC files to prepare the single parts. So these single parts will not be manually cut or manually drilled. It will be all done by machines. In production, once all these drawings are ready and received, production will start. Production is also having a set of stages. First is cut and drill single parts. Then after the single parts ready, you will assemble it to form the assembly element. And this assembly elements is treated, finished against any corrosion. It will give corrosion protections are applied on the structure, and it will be shipped to the desired site location. In production, as I said, NC files will be given to the production team by the detailing engineers. And these NC files are used by the machines to cut the elements. The picture which I shown is a CNC beamliner machine, which used to cut and drill the profiles, eye sections, whatever it is. It can cut to desired length, and it can punch the holes, drill the holes, and desired location. Once you feed the NC files to the machine will read the files. It has all the information about the length of the beam, where the holes are required, where the punch marks are required, where the notches are required. With this information, the machine will cut the beams. So once you run the machine, you will get the single parts ready. This is another machine which is used for PB, mainly for PB members. As I told in the beginning, PB's members are built-up sections which use plates, and plates are welded together to form desired sections. So in detailing, you will be having a single part drawing for each plate. And these plates, these NC files of these plates will be fed to the machine, and the machine will cut the plates based on the required shape. It can cut tapered section, it can cut straight sections, and any notches or cuts, it will cut the machine automatically, and you'll get the plates ready. Once the plates are ready, these plates are joined and welded to form desired eye sections or any box section, whatever sections you are using. These sections are welded by, again, some machines. Here I've shown a continuous arc welding machine, which will weld the web with the flange, and it will be continuous. It will give continuous uniform weld throughout the section. The machine which you are seeing in screen is frame CAD machine. For the LGS structures which we discussed, thin plates are used. These thin plates are fed to the machine, and with NC files you provided, the machine will bend the profile as per your design, and it will punch the holes, it will drill the holes, punch the markings, and cut the members based on the design requirement. Normally the coils are loaded as a roll, so the machine will cut as per the requirement. So once all the assembly single parts are ready, next stage is component assembly. Different single parts are joined together, welded together to get the assemblies. Qualified welders are used for this process, and each welders will be certified to work. And for the LGS, there is no welding involved. The assemblies, the single parts which we get, each channel or Z sections are screwed or bolted together to form the panels or trusses required. Once the assemblies is ready, then this has to be treated. The surface will be having rust, impurities. This will be treated, and primer is applied, and final finish is applied to the structure. Final finish depends on the client requirements, the environmental conditions. If the structure is exposed to harsh environment, a higher level of corrosion protection may be required. And there are different corrosion protection system, epoxy coating, hot dip galvanizing, fireproof protection. Fireproof protection is not just corrosion protection, it protect the structure from fire also. The picture shows a surface preparation machine. It's a sandblast machine, which will blast the surface of the steel. Here you can see the steel's member without before blasting, and you can see many impurities, many scratches, and many rust on the structure. Once the blasting is done, the surface will be very clean, free of all impurities, and this will be painted. Different paint systems are used, different thicknesses are used based on the requirement. There will be client requirement, there will be environmental requirement based on the exposure condition of the steel structure. And the paints thickness are monitored by quality engineers. They'll check the thickness of paint, whether it is adequate. In some cases, client will ask for hot dip galvanized if the structure is exposed or open to moisture, then it will be recommended for hot dip galvanized. In this process, the whole structure will be dipped to hot zinc, and the zinc will get coated on top of the steel structure. So it will protect the steel contact of steel members with the environment with a zinc coating, and this is called hot dip galvanizing. Another painting system is fireproof painting. Even though I've shown this slide in production, it is actually done at the site, because this painting system is for protection from fire. So this specific paint should cover all the steel structure, and it should not give a gap for the fire to enter and get in contact with steel elements. For this reason, the paints are done at site once all the structure is erected and in place. There is two kinds of fireproofing mainly. One is cementitious and one is intumescent. As you see here, this is cementitious. It looks like cement sprayed to the structure. This will give protection to the steel structure. And this kind of structure, this kind of paint system is normally done when the steel is not exposed. It's not visible because it has a very bad look. Another fireproofing paint is intumescent paint. It looks something similar to normally epoxy paint, but you can see all the bolts, everything is painted. So no elements are exposed to heat or fire. So once the elements are ready, finished, next stage is packing and shipping. If you have a project within your country, nearby, land transportation is choose, or if you are shipping to different countries. Here in Middle East, we are doing many projects in Africa and Asia. So we'll be having a lot of structures shipped outside the countries. So containers will be used, which will be loaded to the ships. Here, the important thing is that you have to plan the shipping very precisely. Otherwise, you will waste your money, you will damage its steel structure. It should be packed in a proper way so that the plates or the members should not bend. It should not affect the quality of the structure, and it should not damage the finish system on it. Another thing is that you should have an optimum packing to minimize your cost. So this is the reason I was telling to before, when you design the connection, you should be aware about the length limitations, the weight limitations on transportation. Normally the containers for the shipment will be 12-meter long. So if you have a beam more than 12-meter long, you'll face difficulty in shipment. So the member length, assembly length size should be adjusted for the shipping limitations. Once the site members are shipped, Next stage is erection. As we discuss in detailing stage, we will prepare the erection drawings. These erection drawings will give complete information for the steel components, the assembly numbers, and the location of the assembly and the sequence of erection. This erection drawings will be used by the erection team at site. When you consider about erection, these are some points which has to be taken care. The site condition, safety of employees, erection sequence, material storage, erection equipments. Site condition means most of the steel structures are erected on top of concrete. There will be foundation, sometimes on top of a high-rise building, like that. So you should be aware that the site is ready to receive the steel and there is proper access to site. Otherwise, you will face storage problems. You will bring the material to site will not be ready, you will not get proper place to store, it will get damaged, it will get rusted. So these things should be planned and controlled. And safety of employees is very important because most of them are working at height, so proper safety keys should be there. Erection sequence, the structural stability should be maintained throughout the erection. So the erection sequence should be made to get this stability throughout the erection process. And I told you, material storage is very important. Once you ship the whole steel members, sometimes based on the site condition, you cannot store. For example, if you are doing a steel structure in an urban area where the storage is very limited, storage spaces conditions are really limited. In this case itself, the tower the model which we have discussed is a tower crown, which is situated in a very crowded portion of Dubai. So there, the storage space was very limited. So in that condition, we have to sequence the delivery of the material and erection in parallel. So the erection team should have a plan that they will be erecting these elements, these assemblies, and these particular assemblies are shipped, and there won't be any much storage space used. So once you ship the material, you will erect the assembly. Once you assemble the given elements, by that time the next lot will come and you'll erect. So you won't use much space for the storage. So this kind of planning should be there in the beginning. And you should have an understanding about the erection equipments. So first thing in erection is anchor bolts. You'll fix the anchor bolts based on the anchor bolt drawings. Anchor bolt drawings will show the exact location of the anchors, size of the anchors, and the spacing of anchors. So this, according to these drawings, anchor bolts are placed, and you have to be very you have to take very care about the location of the anchor bolts, otherwise the structure will not fit together. You should have a proper spacing. You should maintain the spacing between the anchors, and you should maintain the critical dimensions between two anchor bolts, because if you deviate from that, the columns will be placed in rock position and the beams or other lateral elements coming will not fit together. So this is a very important stage in erection. Erection sequence. The erection team should be well aware about the structure, and you should know how the stability of the structure should be achieved throughout the erection. Otherwise, even though the structure as a whole is safe, if the erection is done in improper way, there is a chance these columns will fall down, the members will buckle, and leads to the failure of the structure. So you should have a proper erection sequence. In this picture, I've shown a simple warehouse where the erection will be in this order. You will erect first columns, you will erect the rafters, and then you'll erect the purlins and girds for the lateral stability, and you'll erect the bracings. And during this process, maybe you need to use some temporary supports to keep the columns in place, because once you place the columns will not be stable as standalone. So you may need to put some additional supports, temporary supports, which can be removed after the erection. Once the main structural elements are erected, then the last priority will come for the secondary elements like end wall columns, any other secondary beams, etc. And many temporary structures or platforms are used for the access. There are different machines now to provide access to heights. There is man lifts, which can take people at like 35 meters. So people can reach to the connection points for bolting and other fixing other elements. So there are many scaffoldings, rolling scaffoldings are there. This is man lift and this is scissor lift. And erection equipment is very important. Based on site conditions and based on the member sizes, you have to choose your erection equipments very wisely. Otherwise, you will fail at site. Once you complete the modeling, you will know exact Tekla model or any other model will give exact weight of each assembly. So you will be aware about the maximum weight of the assembly in your structure. Accordingly, you have to choose the lift cranes. And also the accessibility of the cranes. If the cranes cannot reach close to the structure, the lifting capacity of the crane will reduce. So these things need to be considered. Here I've shown one diagram. This will help to engineers to choose the cranes. For example, you have a 6-ton assembly. One assembly is weighing 6 ton. Then you need to know for what height you need to lift the member and how far the crane can reach, what will be the boom. For example, this crane can stay here and you need to erect some elements at 24 meters away at 14-meter height. So the lifting capacity of the crane of 35-ton crane is only 1.6. So even if you order 35 ton, thinking that, okay, I can lift 6-ton member, no, you cannot. You can lift only 1.6 ton with this crane. So you have to select your crane, mobile cranes accordingly. Another lifting is equipment is tower cranes. If a project site is having many tower cranes, as I shown in this picture, you don't need to get a mobile crane. You can use this tower crane. And you should be aware about the capacity of the tower crane. In this condition, for example, this tower, this is the model which we've shown. This is the structure you can see here. This is the same structure which I've shown in the model. So lifting of this members, listing of the assembly was weighing around 6 ton. One assembly was weighing around 6 ton, and this total steel structure on top of this tower is around 450 ton. So this single assembly weighs 6 ton, and these tower cranes are used to lift the member. Here we cannot change the tower crane. Tower crane is already there. It's used by different contractors, concrete cladding suppliers and MEP suppliers. Many contractors are using this tower crane. And here what we need to think is we have to take care at detailing stage. You should know the tower crane capacity, what its capacity, and assembly weight. Each assembly weight should be limited to the crane capacity. So we have to think in both ways. If the crane is fixed, if the crane is there at site with a certain capacity, you have to limit your assembly weight accordingly. And if you have a flexibility to change the cranes, and you have to choose the crane to the maximum weight of the assembly. And this way you have to complete the structure with the machineries. And this completes my presentation. And this is the one which we discussed. This is the architectural drawing. This is the erection stage, and this is the complete stage. You can see this is the tower crown this is the model of the tower crown which I've shown to you. structure is at a height of 270 meters. Thank you. Thank you very much.
Thank you, Hashim, for such an informative session. I am very happy that we have so much of participants out there asking so very brilliant questions. So, shall we pass on to the question and answer session?
Sure.
Okay. The first question is from Tausif Kauswala. He's an assistant professor at A.D. Patel Institute of Technology in Gujarat. So he's asking, while designing an RCC structure in StatPro and in ETAPS, why StatPro always gives higher steel?
It is not like that, actually. From my experience, I experience the other way. Whenever I do the design in ETAPS and StatPro, I get lesser steel in StatPro. So I don't know why he got the other way. Because of that reason, most of the companies are not using ETAPS for steel design. As I explained in my slide, StatPro is preferred over ETAPS for steel design. Concrete is the other way, but for steel design, most of the companies choose ETAPS. It's as its own approach. The programs is developed with some formulations and approach and design assumptions and design check at some particular points. So it depends on the design checks where the software is checking the design. So in my experience, I felt StatPro is giving much lesser steel when you compare to ETAPS.
All right. The next question is from Nandkishore Chowgle from MPCOE Ratnagiri. He's asking, as compared to IS, is there any highlighted issue while designing with the other standards?
There is no highlighted issues. Even in India, many of the steel suppliers are choosing American standard over Indian standard because each standard give slight different results. It is not exact same in each standards. And when you go for American standard, it gives like 25% steel less than Indian standard. So most of the suppliers opt for American standard unless it is a requirement. In India, when we do some projects, when I was working in India, client will specifically ask for Indian code. If there is no such requirement, we were going for American code directly because it was giving lesser result. And there is no rules in India that you should follow Indian code or American code. You have a flexibility to follow which code.
All right. The next question is from Dr. L.S. Thakur. He's an associate professor at BITS Education Campus. His question is there any software which does load simulation of these structures to point of failure?
That means he is asking the other way. Normally, all the softwares do, we'll apply the load, we will design it, and we'll get the result for the sections we analyze, or otherwise the software itself will give the sections to be used. So he's asking the other way, what is the maximum loads that one member can take? Normally, some softwares are there which can give the section capacity. For example, in connection design, certain softwares are there to check for the 100% capacity of the sections. So in that case, even then you are giving something. I am not sure about the other way, whether it will give maximum load. It's the other way. Most of the case, it's the other way. We will give the loads and the softwares give the capacity of that particular section for that load.
Right. The next question is from Gaurav Baviskar from DMCE. Sir, can you share your views on steel structures and concrete structures since both have their own pros and cons? Which one do you prefer?
I always prefer steel because I worked with steel. See, both has its own advantages and disadvantages. As far as steel is concerned, the main advantage of steel is it has less environmental impact because you're not you're not touching the environment much. And the steel is, most of the steel structures are prefabricated, which give better quality because it's done at factory with precise dimensions. And you can see when there is a steel structure, the deviation from the drawing is very less. Your tolerance limits are in mm. But when you go to concrete, you are casting at site. It depends on the labors which you have at site, the formwork. You'll be having more deviation from the drawings. So the quality issues are there with concrete structures. And another thing is that steel structures are mostly used for wide span structures. It gives light structure. So these are some advantages in steel structure. When we go to concrete structure, it also has its own advantages. It needs less skilled workers because you don't need any certified welders, you don't need any fabricators for concrete structures, and it is most commonly you don't need any factory facility to prepare the elements. So these are the advantages of concrete. So it depends. It has both has its own pros and problems.
Right. The next question is from Yash Jivani, a student at VSET. What are infill walls in steel structures and why still water retaining steel structures are designed using working stress method?
I didn't get. Can you ask again? Infill.
What are infill walls in steel structures? And he also wants to know why still water retaining steel structures are designed using working stress method.
No, there is no such specification that you should do in working stress. But many steel contractors, steel fabricators, or steel designers still follow working stress method because it's much easier. Working stress methods are most widely used, and most of the softwares are still, most of the fabricators are still using working stress. But it doesn't say that you should use working stress alone. You can even go for limited state design. There's no issue with that.
Right. The next question is from Milan Nakum from UCOE. Sir, any discussion on cold form steel structures and oil gas industrial structures? And what are the main difference in terms of loading compared to normal and PEB structures?
Light gauge structures, as I shown in my presentation, these are very light structures, cold form structures, which doesn't involve any welding. All are bolted or screwed members, and this is very easy in both in fabrication point of view and erection point of view. It won't take much time in fabrication because there are specific machines which can roll the steel profile, which can give the punching drills exact location. So the assembly will be very easy. Another thing is that it's very easy for erection. You don't need any machineries. You can just use hand tools for erection of steel structure. So it is very useful in a small scale construction. You don't need any specific high scale machineries. And when you go about loadings, both conventional steel structure and PB have similar approach of design. The only change in the design is the sections. Instead of using conventional steel sections, you're using pre-engineered sections which use built-up sections. And you use, the main difference is that here you'll use one section for that entire beam, On the other way, you will use tapered section. You will see the moment on stresses at different locations, and you will taper the sections accordingly. Basically, the design loads are the same.
Right. The next question is from Muhammad Adil Ansari, Assistant Professor at Theme College of Engineering. So he's asking, can we do structural audit for steel structures?
Yes, I believe he's checking for the existing structure or what?
Yes, I guess, because he's asking on NDT methods also. Yes.
Yeah.
For the steel structures.
Normally, we do this one when there is an addition to the steel structures. And unlike concrete structures, we don't have any creep issues in steel. So there is the properties of the steel structure which won't vary much with less span of life. So once we have the as-built drawings, once we have all the details of the structure, we can analyze the existing structure and the loading conditions. And there are different methods used for the NDT. We have different NDT checks involved to check the connections, whether the welds are in place, there are rests on the structure. So many visual examinations are done, different NDT tests are done to check the conditions of the structure, and the as-built drawings are used to analyze the structure and to check the stability of the structure.
All right. The next question is from Mithil Naik, our student at VSET. He has a funny question. As Qatar is planning to build modular structure for football stadiums, why isn't such mega structures carried out in a country like India? Is it because of economy or technology a barrier?
It's not like that. Even in India, there are very big steel structures. Even I have an experience when I was working in Kirby. We made one structure in Chennai, which is having around a tonnage of 20,000 ton steel. So there are big structures in India also, and many in India there are many companies doing mega structures, steel structures. Many industrial structures are very big with a lot of steel used.
All right. The next question is again from Tausif Kauswala. He's asking, while designing the cold form sections, IS 801 does not give complete detailing. BS 5950 Part 5 is used for it. Is there any other code which gives complete detailing?
See, here in Gulf, we use mostly American standard. AISI is used for the design of the cold form steel sections, which give all the checks required for the design. And it's fine. It gives all the details. I don't know what he mean by not complete detail, but we use AISC here, and I have less knowledge about IS code because I didn't work for the cold form with IS 801.
All right. My question is, the self-weight of a structure for a steel structure is very high. So can you give a highlight on the foundation design of these structures, as if who does these designs?
That statement is wrong, actually. The self-weight of the steel is less when we compare to concrete structures. Normally, the steel structures are very light when we compare to concrete structure. That's the main advantages of the steel structure. For almost all the warehouses, the foundation will be designed for the uplift, not the weight of the uplift from the wind will be governing for the warehouse structures, and wind load will be governing the foundations. When you tell about the design of the foundation, there are two cases. Either the steel structure engineer itself will design the foundation, or the reactions will be given. As I told in my presentation, in design stage, anchor bolt drawings are prepared, which shows the base plate locations, anchor bolt locations, and the support reactions are given for each location. This will be given to the concrete subcontractor or concrete engineer, and he will be designing the foundation, because most of the steel will be the steel fabricator itself will be having in-house design team, and he will be designing the steel. So it's his scope of work to design the steel, but the foundation will be done by some other contractor. And because of that, the steel supplier won't design the foundation. He'll just pass the reaction coming from the steel, and to that reaction, the foundation will be designed by the concrete structural engineer.
Right. The next question is from Sandesh Utekar from VSET. Which has been the most challenging project that you have worked till date?
It's very tricky question, actually. I've done one mall extension here, which is a very famous mall, Marina Mall. We added one story to that mall, which was completely done by steel. The main challenge in that project was it is a running mall, so we have a very restricted access, and there is these elements which we fabricate has to be lifted from a far point, and we cannot, the existing structures has many limitation to take the loads, and the cranes, there is a basement around the structure, so the cranes cannot go close to the structure. It has to be stayed a bit far away from the structure, and the structural elements has to be lifted to the point. So the crane capacity, as I discussed in my slide, when we go away from the structure, from the erection point, the crane capacity will reduce drastically. So we have to limit the element sizes, and the shape of the additional structure itself was curved with a two-dimensional curve. So this was also limitation. And another limitation in this project was there was an cables going on top of the structure. So we need to take care about that. We need to avoid the clashes on these cables. And there were too many MEP, because you might have seen all the structure, the roof will be fully filled with MEP decks and machineries. So any platforms running over it need to be well coordinated with this MEP distributions. So there were too many coordination involved. Apart from design, it is practical issues which we face. And the elements need to be designed, small elements need to be designed. And this was a bit challenging. When you consider about design limitations, yes, we did one assembly hall in Pakistan, which was very wide structure, like 50-meter span truss with concrete on top. So it was heavy. So this is we received, and the support points, the structural supports were limited. So we were using different complex arrangements to get the structural sound and safe.
Right. Now, this is a general question. You know that steel structures are good conductor of fire as well as heat and all. So what are the treatments or preventions that you do for the same?
Two cases are there. One is heat, another is fire. Temperature checks are done for the steel structure. When it is a wide span, heavy sections, we do analyze for the temperature, and it will calculate the stresses created on the steel elements due to the change in temperature. So this analysis is carried out where we use different range, especially in Gulf, we have a temperature variance of around 40 degree. In cold winter, we'll go up to 10 degree, and in summer it will reach up to 50 degree. So there's a big difference of 40 degrees Celsius. So most of the structures are, when it is wide span, we are analyzing it for the temperature change. So this will give the stresses induced, the elongation limits are checked, and the sections are provided accordingly. And for long span, expansion joints are provided. For as per steel, expansion joints are less required because we don't have any crack issues in steel, and steel are more flexible than concrete. So Expansion joints are comparatively less when you compare to concrete because of these advantages. And normally for steel structure, expansion joints are provided at every 120 meters to accommodate the changes in dimension. And when you come to fireproofing, nowadays almost all structures are fireproofed. There are special paints used for fireproofing. It will calculate, there will be different requirements for fireproofing. For example, some clients will be asking for 1 hour fireproofing. Always fireproofing is explained in terms of hours that it can resist the fire. So some clients will ask for 1 hour fireproof. Some clients will ask for 2 hour fireproofs. So based on the requirement, fireproof paints are applied. There are different kinds of fireproofing paints. Cementitious paints are there, intumescent paints are there. Cementitious, as I said, it's a cementitious base coat over the structure. It looks very bad, but it will serve the purpose, and it is cheap when you compare to intumescent paint. It is like 30 to more than 50% less price when you compare to intumescent paint. So if the structure is not exposed, if the structure is cladded, almost all the contractor will go for cementitious paint. But the structure, if it is exposed, it has an architectural importance, then intumescent paints are applied. Intumescent paints looks something similar to epoxy paint, which will be having good finish, and it can resist fire also. Based on the requirement, how much hours of fireproofing are required, there are calculations to get the thickness of the paint. The thickness of the paints depends on two criteria actually. Member sizes. When the thickness of the steel is high, you need less thickness of fireproofing. When the thickness of steel is less, you need a thicker paint system to get to achieve required fireproofing. And based on the hours, how long you need to resist, the thickness will vary. This is how we protect steel from fire.
Right. And especially in UAE, you have a lot of structures which are in sea. So
Yes.
in underwater. So is there any particular design criteria while you design those kind of structures?
For exposure that has saline exposure, the main thing which we are considering is protection for the steel. Offshore design is separate. I'm not talking about the offshore design. Offshore design, when you go for offshore design, offshore forces are considered like drag force, wave force, wave hitting force. And these forces are considered. And when we go for winds, we have harsh wind conditions, so wind loads are considered accordingly. When you go to onshore conditions, when it is close to the sea, we have again the wind loads are considered as per American code. We use exposure D conditions, so this will give high wind loads on the structure. And for the quality of the structure, there is marine grade coating systems, and these marine grade coating systems are applied, which has high resistance against corrosion, so it will have high level corrosion protection for the steel.
Okay. Now the next question is from Vikram Singh Jadhav. He's asking, considering the strong advantage points, can aluminum alloys material replace steel as structural material in future?
Aluminums are already used in steel construction, but it cannot completely replace steel. Maybe in future, no, but now, not now. Aluminums are mainly used for mullions, as I told, claddings, cladding, curtain walls, mullions, aluminums are used. And even small lower span structures, aluminums are used. Aluminums comparatively, when you look the stiffness, it is much less yield strength. When you compare to steel, it's like almost third of the steel. So it has its own limitations, but it is used. And aluminums are used for many structural elements, but not for heavy elements.
All right. Now, the next question is from Preeti Nagargoj from Vimet. She's asking, what are the various provisions of design of steel chimney structure? steel chimney structures?
What she's asking, different provisions?
For the design of steel chimney structures.
Steel chimneys, I'm not much familiar with steel chimney structures, to be frank. So we didn't do any chimney in steel structure. We have worked with some power plants, but that used concrete structures, and we use steel supports to that one. So this, I'm not that experienced to answer this.
All right. The next question is from Geeta Prajapati. She is asking about the demolition methods for steel structures.
Yeah, when it comes to demolition, it's easy compared to steel because most of the steel structures will be bolted, and same like erection sequence, you should have a stability check for the dismantling of the steel. So when you remove one element, you should know this removal will not affect the other existing structure on existing structure. Maybe in some cases we'll be using secondary supports for the stability. And since it's all the connections are bolted connections, it is easy to dismantle. It's the same reverse method of the erections. You should have a dismantling sequence plan. You should have machineries and temporary supports, and it's just removing the bolts and dismantling the structure. When there is a welded connections, there are machineries, there are equipments to cut the weld, gas cutters are there, and so machines like that which can be used to cut the steel.
All right. Now the next question is from Khan Hufaiza, who is a PG student at AIKTC Panvel. He wants you to compare the life comparison structure life for RCC and steel, and he wants your view on which is more beneficial for green building structures.
For steel structures, normally it can go like 40-50 years, but contractors give for a span of 20 years. This is the warranty period for the structures, but it will be sound enough for there are structures still standing for more than 100 years. If Eiffel Tower is one such example, it's more than 200 years. So steel, if it is pure, if the corrosion protection is proper, this is the main problem in steel structure. If you have a very poor quality of corrosion protection, and if the steel grade which you are using is not good, it can get corroded easily. So if we are using a proper good quality steel and good quality corrosion protection, it can take a long span. It can withstand a long span. And when you compare to environmental impact, of course, steel is as much environment friendly because it is not damaging the environment much, and it is also called a green structure in most cases. If the raw materials can be recycled, the steel, once you dismantle steel, this steel can be recycled to form new steel structures. So your wastage will be less, and it has less impact on environment.
All right. Now, next is again a personal question from Viresh Tadolge of VSET. He's asking, do you have any failure experience of any of the projects, and how do you handle such?
So far, no such experience. We had some issues in erections because there was, if proper support members, as I told, if during erection, even the structure is safe, if the erection is not followed in proper sequence with proper temporary structures to support the elements, there can failure can happen. We had one such incident in my life where they erected the columns without any lateral supports, and one day there was a heavy wind and one column buckled. So this was one experience in my life, but then we replaced that column with new column. There is no such failure experience for the erected steel members. Everything is sound and good.
Thank you. So we've come to an end of our QA session.
Thank
So
you.
I would like to thank Hashim for such a wonderful, informative, and insightful session. And as for a civil engineer, we always believe that steel and concrete are vital like oxygen. And I'm very much sure that you have reinforced in curiosity, generated interest and thrill for so many of our viewers listening to you who are in love with the design consultancy jobs. Now, I would request Professor Arbaz Kasi, who is Assistant Professor in Civil Engineering Department, to please deliver the word of thanks.
Good afternoon to one and all. Myself, Professor Arbaz Kazi, on behalf of Department of Civil Engineering at Vidyavardhani's College of Engineering and Technology, takes this opportunity to thank Engineer Mohammad Hashim sir for sharing valuable inputs and experience about basics of steel structure construction. There was so much of learning today from your lecture, sir, on the fundamentals of designing, drawings, software, career insights, and many more, which would definitely help our participants to help in their career building. Thanks once again for sir for the wonderful session and to all our viewers for making this session interactive. Thank you. Stay home, stay safe, but keep learning.
Thank you. Thank you for giving an opportunity.
Thank you, Arbaz sir. I would like to thank our participants for your overwhelming response. We have had over 1,000 views for each of our sessions, and on behalf of the entire Civil Engineering Department, I express our sincere gratitude for making our first ever webinar a huge hit. Tomorrow, we have our last session of this journey, which is on the topic Deep Excavation in Urban Areas by Dr. Jitesh T. Chavda, who is an assistant professor at SVNIT Surat. Also, for all the parents and students out there, Civil Engineering Department of VSET have organized a student development program, again free of cost, from tomorrow till 21st on career planning and preparation for competitive exam at 4 p.m. to 5:30 p.m. We have a very wide range of speakers who are alumni of our college. Kindly use the link to register and subscribe to our YouTube channel for all updates from the department. With this, we have come to an end of today's session. Till we meet again tomorrow with our last speaker, stay safe, stay happy, but keep learning. Have a good day, everyone. Thank you.